Good morning and good evening for those in Europe and Asia. Welcome everyone to coming to the second episode of our webinar series, Real-Time AI, Speed, Spend, and Solving Control. My name is Hao Lin from ScitiX, and I'll be your host and moderator today. We all know the promise of autonomous voice agents and interactive AI, but the production reality is brutal. High latency and ballooning token bills are destroying user experiences and killing margins. But today we're moving past the hype to talk about physical reality. I'm joined by Stefan Ideler from the infrastructure powerhouse i3D and Daniel Usedom from the team pioneering next-gen agentic applications at ThinkingAI, of course, as well as our very own Scott Wolk. Now, I'm going to the speakers for a quick self-intro. Stefan?
Okay, I'm Stefan Ideler, one of the co-founders of i3D.net, so been with the company more than 22 years. As you mentioned, i3D is a global infrastructure provider, which is origin in the gaming industry. One of our parent company is Ubisoft, which is also a gaming powerhouse. And one of our core strengths is offering these solutions not only within the gaming industry anymore, but all adjacent industries as well who need flexible capacity to solve the hybrid problems that you have nowadays. Thank you.
Thank you, Stefan. Dan?
Hey, everybody. I'm Dan Usedom, and I'm on the US go-to-market team here at ThinkingAI. I've been in the games industry for the past decade at companies like Unity and Roblox. ThinkingAI is an agentic engine for real-time agentic growth. And it's powered by our behavioral analytics and engagement platform that's used by over 1,500 customers globally. At our foundation is this best-in-class analytics and engagement platform, which is now used by agents across analytics, engagement, testing, as well as data tracking. We built out hundreds of skills for these agents to use our platform to offload manual tasks across your teams to improve your most important metrics like revenue, like retention, and customer experience. Top grossing mobile teams like Century Games, Krafton, Sega all rely on ThinkingAI to power their growth. I'm really excited to be here today and talk a little bit more about what we're doing and apply it across the topic.
Thank you, Dan. And last but not least, Scott?
Hi, I'm Scott Wolk. I'm the lead AI solutions architect at ScitiX. ScitiX offers a full stack AI platform built on NVIDIA Blackwell and Hopper chips. We support customers with GPU compute, RL post-training, and production inference. For 20 plus years, I've worked in security and infrastructure, and today I help companies leverage the model mixes that best suit their needs. Look forward to getting into it.
All right, it's going to be a great discussion. Let's dive right into it. So when we talk about the paradox defining enterprise AI in 26, the price of tokens have collapsed, but the AI bills have exploded. Really, on average, enterprise AI budgets have gone from about $1 million a year to $7 million in the last 2 years. And this is the first year companies are spending more on running the models than training them, right? So really, token costs are now a board level item. So how did the industry that mastered efficient infrastructure a decade ago, like gaming, solve this? Stefan, let's start with you.
That's a very good question. Especially in the gaming industry, AI is already being very widely adopted because essentially you're creating software, but then software for games. So there's not a gaming company out there who doesn't use stuff like Cloud Code or Codex or Copilot. And then also that controversy about using it for art and so on. But the biggest problem right now is indeed, as you say, every gaming company that I talk to is like, great that we did token maxing, that we encouraged AI use of all of our engineers, but now these enterprise subscription plans are going through the roof. It's almost more expensive than hiring actual people, or even it is more expensive than hiring actual people even at this point. How do we solve this? So what we see when we talk to our clients, the ideas that are being pitched is, can we maybe use like an AI gateway router to maybe separate all the queries going to Anthropic, but have maybe self-hosted models that can do the bulk of the easy work and only do the more expensive queries to the more advanced AI models. And that's kind of the challenge that we're seeing right now. How do you do this, and how do you make this happen?
That's great, Stefan. Scott, I think this is running wheelhouse. What do you have to say about that?
Yeah, so let's set the stage. So token prices, have collapsed. Yet bills have tripled. Inference is now 85% of the enterprise AI budget. This is the first year inference outspends training, which is a milestone. So, but let's look at a real world example that happened with Uber. Probably most folks have heard about this, but let's just go over. I think it's a pretty good example. They handed thousands of engineers Claude code and said, "Hey, go nuts." Well, the engineers burned through their whole annual AI budget in 4 months. And Gartner forecasts that inference costs will get to 90%, will actually be 90% cheaper by 2030. However, agents, burn through tokens much faster than humans. And we're already seeing agentic spend hitting 206 billion this year, and that's up from 86 billion from last year. And that trend's only going to continue. At ScitiX, we believe the correct move is to match each workload to the right model. And for most of what enterprises run, an open weight model will work at a fraction of the cost. So the gap between closed weight and open weight has essentially converged at the coding and agentic task level. The gap, survives mainly at the hardest reasoning and multimodal level. So it's not necessarily go all open. It's stop paying frontier prices for work a right-size open model does well. In April, GLM 5.1, which is an MIT licensed open model, briefly took the #1 spot on SWE Bench Pro over GPT and Claude. Now, even though it didn't stay on top that long, the point is that an open self-hostable model got there at all. When you right-size and run open weight models, you can save 60 to 80% on production workload cost. Recent benchmarks showed 94% decrease in cost running Kimi 2.7 versus the latest frontier model, Fable 5, before they took it away. One of our own customers realized 60% savings moving workloads from OpenAI to comparable open model. Now, to be clear, sometimes the honest answer is a frontier model. For the hardest reasoning and true multimodal task, a closed model might be the right call. And we'll tell you that. The win isn't open versus closed. It's not overpaying for the 70% of your traffic that doesn't need the frontier. Dan, what's your take on this topic?
Yeah, we actually had a dinner last week with a bunch of different AI leaders in the Bay Area that are in town for a conference. I think this was one of the major topics at our dinner, was just how teams are starting to manage their token spend. I think, like Stefan said, token maxing, having a leaderboard who uses the most tokens, I think is something that people are starting to shy away from and starting to need to see true ROI on their token spend. So, what we're seeing teams do is start to tie back token spend to improvements across their games, whether that be improved retention, improved revenue. If we're using agents like on ThinkingAI, to help with analytics and A/B testing and engagement for your user base, we want to see an improvement from this token spend across our games or applications or whatever you're using these tokens across. So that's something that we have kind of firsthand experience seeing, is teams moving away from just the experimentation phase now into needing to see true ROI so they can have a little bit more solidified token budgets in the future and know what that sort of is going to be the return on your investment as you're sort of utilizing tokens across your different teams. What we see too is a lot of teams are still working siloed across their agents, which causes a token visibility issue. So teams, individual teammates have their own flows and their own agents. What we're helping teams do is actually consolidate their agents onto a control plane where they can choose which model is best for each job, see what each agent is doing, as well as control your team of agents in a much more consolidated way, as opposed to everyone working in siloed sort of environments with their own agents. So those are a few things that we see as far as token costs, moving away from experimentation to now needing to see ROI, and also having better visibility into what's happening across your different agent teams and needing a more solidified way to understand what your agents are doing, just as you need to know as your real teammates what they're doing as well. So that's a little bit from our side what we're seeing here today.
That is a very interesting take. Very different angles from Scott and Daniel. I think from Scott, it's really not using frontier for everything, right size the models for the right workload. And then from Daniel, your perspective, it's kind of having a control framework, right? And having better visibility and tying token spend to ROI. So I think the three of you actually can really work together more. In reality, I think that's really gonna probably be the best answer, for the customers, being sticker shocked by their monthly bills, right? Okay, so that's cost. That's one constraint, but speed is another, right? Now we're talking about voice agents, in-game AI, interactive copilots, real-time agentic player, analytics and engagement. These don't just need to be smart, they need to answer now, right? So a lot of times they can't wait 1 or 2 seconds, before the answer comes back. So, before we get into that, let's establish what's at stake. So Dan, your thoughts on that?
Yeah, and we've been working in the games industry for the last decade plus with some of the top grossing mobile teams. And what these leaders that we're working with now are asking us is, what are they doing differently to win? What are these top grossing teams that you work with doing differently to win? And speed and the real-time infrastructure of ThinkingAI is really one of those main points that helps these teams win. The teams that are winning right now are the ones that are making decisions the fastest, the ones that analyze users, test messaging and offers, and deploy personal engagement campaigns faster than anybody else are the ones that are seizing those opportunities and winning when it comes to the marketplace. I think when you look at a platform like a Roblox, like they have trends on the platform. As soon as something becomes live, let's say there's a trend on social media, those games are implementing that within hours. And other apps and games are expected to now work in that similar way as attention span becomes shorter and shorter. So at ThinkingAI, what we're doing is providing that infrastructure to pull real-time analysis and have agents working across all those important business functions, so your team can interact with users in the most streamlined and efficient way. For example, you can have our agents surface findings. Let's say there's a drop in D7 retention, straight to your Slack channel as soon as they detect an anomaly. And then from there, you can jump onto the ThinkingAI platform to work with agents to diagnose the issue, as well as create a plan that we can engage with those users to improve D7 retention. You can then test it to a small group of users and then roll it out live to your entire user base, all within the agentic engine. So that's what we talked about, that sort of real-time aspect of our engine that now powers our agents is what teams are using, or how teams are now kind of expected to use that sort of real-time infrastructure to make decisions that have the most impact on their game. So that's where our platform kind of comes in, is to provide that sort of command center for agents to detect, test, and deploy these campaigns that can really have the most impact on your game as fast as possible.
That's really interesting. Stefan, I'm sure you have a lot to say about this topic as well.
Of course. What we see in the newspaper nowadays, it talks about another 500 megawatt data center here, another gigawatt data center there. But that's just the tip of the iceberg. That's the data centers you need to build your models, to maybe further train your models as well. But what we need after that, after you have your model, or you pick the model on Hugging Face and you just want to use that, and you want to use it in your applications, in this case, in our case, for example, in the games, where we see a lot of games in development which are using enhanced AI-like features, like AI teammates who respond to your voice command, who act as a real teammate to you. There was a recent game out already, like Where Winds Meet, where when you were chatting to the NPCs, the text was dynamically generated by AI. That can still deal with some latency, but when you're talking about actual live teammates, that needs to be as close to that compute as possible. So what we've seen is, over the past couple of years, that compute, of course, moved to the edge to serve the players better in a more optimal way and better player experience. And what we are moving with at IT3.net is also making sure that we have that inferencing capability at the edge. So that's actually executing the models that you've already built and trained at every single edge location to really guarantee that the latency is as low as possible to the applications, in this case, specific example, the game servers, or even the game clients need to be. And I think that's something that in the current discussions is often overlooked. And it's not just within the game industry, it might just be the one running into this problem the fastest. But I think every single enterprise application which relies on user latency for a good user experience will also need that inferencing close to the edge as well. Yeah.
Great take. Scott?
Yeah, thanks, Stefan. Thanks, Hao. So, for speed, I think the number that matters for anything interactive isn't tokens per second, it's time to first token. The pause before anything happens. Under a second feels like a conversation. Over 2 feels like you're waiting on a fax. I'm kind of dating myself with that reference, I think. But so here's a real world example. Like in a public demo at AI Builders Denver recently, an open model on our stack hit first token in about 700 milliseconds against Claude Sonnet's 1051 milliseconds. So first to speak at a 1/9 of the cost for that run. On embeddings, the hot path for any retrieval system, our open models came back in roughly 200 to 300 milliseconds versus 1700 milliseconds for closed option. So it's 5 to 9 times faster. First token speed and retrieval speeds are where real time actually lives. A right size model has less to compute before first token. And an open model lets you optimize the serving stack yourself instead of inheriting a black box API's latency profile. And if a workload genuinely needs a frontier model, you can still put it behind the same caching and routing. That architecture helps in either case. And when you turn on reasoning mode, it gets worse for the big closed models. In the same public demo, flipping thinking on pushed latency from 7 to 24 seconds on Claude. And across the field, extended thinking inflates time to first token many times over. For a voice agent or copilot, that's downright unusable. Right sizing isn't really a compromise. For interactive work, it's often the only thing that fits. And our strategy is to route the easy queries to a small model and save the big one for the hard ones. The average latency drops, and so does your spend. Speed and spend are the same optimization. But here's the dimension we don't talk about enough. Speed isn't just how fast you answer, it's whether you answer at all. The frontier models have real repeated downtime. Heck, it's on their own public status pages. Just check them out. And even while up, their tail latency spikes past 1 or 2 seconds under peak load, while dedicated self-hosted capacity stays predictable. Shared GPU pools can give you noisy neighbor spikes. We run dedicated capacity so the tail stays flat and predictable. So real time to me means real time you can put in front of customers, fast and dependable on first token. And dependability and data control turn out to be the same instinct. Own the stack and you control the outcome, which leads into our next topic.
Great summary, Scott. It really sounds like performance is really not negotiable, for a lot of, real life use cases. Certainly not in gaming, but also in many of enterprise scenarios. But fast and affordable still isn't enough if your regulator or your customer says the data can't leave the building or the country. Sovereign AI has gone from buzzword to procurement requirement, and it's also become one of the biggest bottlenecks for widespread enterprise adoption. How do you view these stuff, Stefan?
Sovereignty is always a hot topic, especially in the field of compute and storage. It's been a very hot topic, at least here in Europe, over the past year and a half, for various reasons I don't have to go into. But people didn't really think or give thought about AI models yet. They loved using them. Cloud Code, fantastic. And also last week, or the week before, felt like I was conquering the world using Fable. And then suddenly my toy was taken away from me. And that fact alone caused a massive shift in thinking at many of the companies that we talk to. The realization that the model that you rely on is suddenly no longer available, or the frontier model at least, makes it now an extremely important topic, where before it was more thought like, okay, if we can at least point where our storage is, where our compute is, that we talk to a model, fine. It was kind of not on the table. But now it is extremely relevant in many of the conversations that we're having, which ultimately also leads to having the discussions of maybe use open models that you can point where they are running. It's totally a different strategic outlook. Yeah.
Dan, what are your thoughts?
Yeah, I think this is one of the core principles of Thinking AI, and we built our platform to be self-hosted, so teams have complete control of their data. It was really a non-starter for many of the teams that we worked with when some of our co-founders started our company, and now we continue to build on this importance of having control over your own data. We are now building this sort of platform that allows teams to really build a knowledge base, a strong knowledge base across their data, and have agents that learn and grow across your knowledge base, that aren't going all over the place and delivering hallucinations, and providing answers that may not be satisfactory for what teams need. So the self-hosted, secure data is one of our core principles too, and obviously one of the most important things that we see for growth moving forward. I think we see more and more teams moving away from all these different maybe point solutions across AI to more consolidated planes, and that are on their secure data sets. So I think what we see is some of these teams that are gaining the real advantages are these ones that can access and work off of their unique data sets. And that's where we help those teams sort of set up the agents across those unique data sets, and grow and provide these sort of agents that can really impact their business. So all part of that is sort of this data security and data ownership piece, which is one of the core sort of principles of Thinking AI, and what we see so many teams, so now worried about and concentrating on, I think, in this next wave of AI growth.
Okay, so Stefan is on really a physical boundary, and Daniel, you're on data sets. Scott?
Yeah, so in the public demo I've referred to before, our customer made a deliberate choice not to route their traffic through a large frontier lab, not because anyone is accusing those labs of misusing it, but because when it's your customer's data, trust us isn't a control. They wanted their data on infrastructure they could actually trust. That instinct is showing up in more and more enterprise deals. And here's why that instinct is right. when Anthropic shipped Fable 5 in June, it came with a mandatory 30-day retention, and existing zero data retention agreements no longer applied. To be fair, they don't train on it. But the point is, with a third-party API, the data terms can change with the next model release, and you find out after. On infrastructure you control with open weights, no vendor can revoke them. And it's worse than most buyers realize, because a lot of the inference providers out there don't even own anything. They rent GPUs from someone else's cloud. Your data passes through their layer and the underlying provider's layer, and you got even less visibility into how it's handled. We own and operate our own clusters, Blackwell and Hopper, in our own facilities. Means fewer hands are on your data. So zero data retention, your prompts and outputs aren't kept on hardware we own end to end. That's a different category from trusting an API's terms of service. And open weights can make full sovereignty possible. MIT license models like GLM 5.1 give you frontier class capability. You can host in your infrastructure with no token leaving the building. For workloads that demand a closed model, you can make a clear-eyed trade between capability and control. But the point is, you choose per workload instead of sending everything to one outside lab by default, which is, the thread through this whole panel: speed, spin, sovereignty. They really aren't three problems. They're one architecture. We feel, open weights on infrastructure you control is a solution.
Thank you, Scott. We're going to have a bonus round today because we have a couple questions from the audience live. So not everybody needs to answer. If you got a good take, please share. So the first question from Alman Zologic. Token cost per inference is a wrong unit for transactional AI. A failed agent run that retries 3 times costs more than a completed booking, even if token count is lower. So cost per successful outcome is what matters. Are enterprises measuring it that way yet? I think, Stefan, you had something to say?
Well, I think this is more for the rest of the team. I can say that this is a topic that is very hot on our minds right now, and also from the clients that we talk to. The companies are on the front end of the AI curve are now dealing with this problem. How do I find the ROE of my tokens instead of token maxing? And I think this is a very, very valid measurement point to consider. Retries versus completed successful queries. Personally, I have not figured this one out yet, but maybe one of our other speakers have.
Yeah, I think just chiming in on this really quick, it kind of goes back to what we talked about in the first part as far as moving from experimentation to now tracking ROI. I think we see teams be more successful on getting answers or successful outcomes by creating a more consolidated place for agents to work, and also expanding and having those agents learn off of each other. I think we see that outcomes become more successful when the information in that data is in a more consolidated manner, as opposed to teams working all over the place and agents having to move from tool to tool. So yeah, I think that all goes back to that ROI question of how many retries or whatever you want to measure for a successful outcome. We want to see clear ROI when we're using tokens, when we're querying our agents, when we're working with them. And that comes back to creating a strong platform for those agents to work across to reduce kind of the issues that we see now.
Thank you, Dan. Scott, do you have a take?
Yeah, I mean, I totally get where Alman's coming from. I mean, that's definitely a great way to look at it, and I think we will move more that direction, but I think it's still kind of a hard problem to solve, so to speak. we've seen issues before where, depending on the prompts, right now, even depending on what model you're using, you can have different token counts. So, doing something on, this open model versus, a frontier model, even, even between different models, you can have completely different token counts, input or output. So it makes it even kind of a harder question to answer. I think at some point, it's kind of, I always refer back to before you used to have all the cellular companies competing on, you only get this amount of minutes for your cell plan and stuff like that. And that's kind of right where we are with tokens right now, which is super annoying. I'm hoping that, wouldn't it be great if we could do unlimited plans? I mean, at some point, maybe we can get there, but there is a real cost to, hosting and running these models. You've seen all the AI data centers come up. There's huge costs there. So I think, it's still really, the whole industry, right, is still very kind of immature and coming up to speed, or it's in the early years, and we're figuring this stuff out. So I agree, if an agent's going crazy and it's still not answering something because of a technical glitch or whatever, it sucks that you're getting charged for it. But at the same time, you might have to look at, well, are my requests still, going through? So, again, I think this is something we'll get to, but I don't think anyone has the answer yet. But we're still working, I think, on getting out of this, per million tokens cost and doing something different. In fact, for some text-to-speech models, actually, they're getting out of tokens. We're actually charging per audio minute, which is more meaningful. So I think we'll get into more things like that based on the model. It might be kind of more outcome related versus just spending all these tokens. And I think that's a great take that, if you can make it to where it's kind of more results driven, there can be a trade-off.
Scott, you spoke my mind. I was going to mention the same thing. I think, it will probably be up to the providers, really changing the way that they charge, and they won't do that until enough customers demand it, right? And there are options, right? So today, if OpenAI, let's just say hypothetically, OpenAI decides to charge result based, then and people actually vote with their actions, then you can bet Anthropic will probably do the same thing and follow suit, right? So I think, yes, just like Daniel said, there's an element of having a control framework and being able to follow your tokens. But on the flip side, I think the provider's pricing model had to catch up.
Yeah.
So thank you. Second question and last question from Roy Tao. From an infrastructure side, how do compute providers handle sudden massive spikes in concurrent AI requests during the game peak hours without degrading time to first token? Do you see specialized hardware or customized inference engines like VLLM becoming a mandatory baseline for gaming backends? I'll go to you first, Daniel.
Yeah, I think this is something that our team probably doesn't have too much insight into. But I think just from like I said, we set our system up to be real time, to maximize that time or minimize the time to first token. And, we want to make sure that we provide the best option for LLMs too, for teams to use for different tasks. So I think that's from a high level, our quick response, but I'll pass it on to the other two to chime in here.
Stefan, anything to add?
Yes. So how currently most games operate is that you have an optimized layer running in bare metal data centers, and then you have a flexible component during the peak hours, which gets scaled up to cloud. So what we usually do for those games normally is we benchmark the application then to see, okay, how many applications can we fit on a single compute, and how many compute do we have available? So it's kind of a logistical puzzle. The same we see now happening with the games in development. What's the peak load that a full service session can generate in terms of token requirements, in terms of capacity? And then you have to, again, play the logistical puzzle. How many total amount of game servers could we support maximally in one location on, indeed, the specialized inferencing hardware that we are currently utilizing in our different data centers. The problem then is still not all current traditional cloud providers are suited to also run tasks at scale like this. So I do think we'll see a shift where we see new providers in the mix, which can help us deal with the burst or the peak load of these games, and that will require having the compute very close to the inferencing capabilities. It doesn't even matter if that cloud provider is latency-wise a little bit unoptimized, as long as still then the inferencing is close, because ultimately that will be a bigger impact on the player experience than 5 or 10 milliseconds more latency to the player due to the distance. So yeah, it's just like with normal capacity, this will also be a logistical puzzle. Advantage is that most games have a peak in the evening of each time zone. Then during the day, you'll have more capacity free on your dedicated inferencing hardware to utilize for, let's say, enterprise workloads, which peak during the business hours. And that's the puzzle I think many compute providers are and will have to play. You will also see compute providers who will probably overbook the hell out of it, and that will lead to a degraded experience. And then, of course, it's going to be a mix and match of the parties how they will approach this. Yeah.
Thank you, Stefan. Any closing thoughts, Scott?
Yeah, I mean, I think Stefan answered it pretty well, but coming from ScitiX's point of view, since we do host our own GPU, host our own models, and then also allow customers to host their own models and train. There's a couple different things. One is that, yes, I mean, sometimes a kind of a shared model as a service is the answer, but that's generally when you want to save on costs. But again, if you need something that's really performant and can impact your customers, then you always have the option of doing more of a dedicated cluster, and kind of going back to the old Kubernetes where you can auto scale up and down to kind of right size your cost. If you're pay as you go for GPU resources or whatnot, that can be a lot harder because GPU resources, honestly, is like once you get them, it's kind of I think a lot of folks have run into this issue. It's hard to give them back because you're not sure if you're going to get them back when you need them. So a lot of times it's just right sizing your cluster, doing the load testing. The same traditional software techniques have gone back since the beginning of time. There's no kind of getting away from those things. We were talking, this was interesting about customized inference engines, because, we were actually just talking to a storage provider about seeing how we can optimize KV cache, because on the inference, one way you can really improve performance is basically just using your cache instead of, hitting disk. I mean, that's pretty standard practice for lots of things, right? But even on these AI models, it's heavily dependent on cache if you want really great performance. So, one thing that we were looking into is we've made a lot of optimizations with KV cache, and that's what certain inference providers can do and some can't. But it's pretty interesting because, yes, we've seen it where we've seen customized VLLM repos that's customized with InfiniBand and certain storage, and basically, can really optimize and make huge strides in terms of if you compare, with and without, and especially when you scale up, 200 concurrent, 500 concurrent, then it can make a significant difference. And that's where we're kind of optimizing is optimizing that KV cache hit rate. And that seems to be something that is useful for our customers.
Thank you, Scott. What a fascinating discussion. There you have it, folks. Basically, speed, spend, and control in just under 40 minutes. So just one last time, let's hear from the speakers for parting thoughts. Stefan?
So when you asked me a couple of years ago and asking me about AI, is the hype, is the bubble? I think we're pretty much beyond this question now. I think all of us, and also the audience, are aware AI offers significant productivity increases. But the topics in this webinar, in this live stream, are extremely relevant to all of the clients that I talk to now. It's about the spend, it's about the difficulties with the enterprise subscriptions, it's about the business continuity risks. What if a model gets pulled? What if a model is an outage? What if the price gets hikes? And nowadays, more recently, where is the model running? Where's my data? So I hope that the people attending found this useful, and I'd love to stay in touch.
Thank you, Stefan. Dan?
Yeah, I think building off of Stefan too, it's moving from experimentation now to needing to see clear ROI. It's starting to consolidate your clear agent teams too, if you're using agents, or consolidating your different solutions, as well as managing that spend in more efficient ways too. It's not just a free-for-all and go out and spend as much money as you can. Like, let's start to be a little bit more thoughtful about how we're spending across our different AI solutions, and making sure that you're building out a strong knowledge base too that reduces the amount of hallucinations or issues that you see when working with AI too. I mean, the productivity gains are real. We're starting to see real gain when it comes to ROI from a business case as well, and I think all of these topics are very important, and there's ways to manage all of these different challenges. And we're always here to talk if anybody on the webinar wants to have a deeper conversation about these.
Thank you, Dan. Scott?
Yeah, so I think from our perspective, it's really right model for the right workload, and then when you kind of make it efficient and optimized in that manner, you're going to see some real reduction in AI spend, and you'll also most likely have increases in performance, and again, tighter control of your data. So just as a shameless plug here, ScitiX, we're offering a free model concierge service, so you can kind of think of it as an audit of the models you use. You just bring us your most expensive workload, and we're confident we can find the right mix of models to lower your AI spend, and that's free of charge. And I just want to thank Hao, Stefan, Dan, and all our attendees for attending today. Really appreciate it.
Thank you, Scott. I think I speak for everyone on the air today that we would welcome discussions around the challenges your company is facing around these issues. So here are the QR codes that you may use to get in touch with the speakers today. Just give it a moment to show up. I welcome you to tune in to our YouTube channel for the replay of this discussion and be in the know for the upcoming episodes of the webinar series. I want to thank you, Stefan, Dan, and Scott, for offering a ton of insight today on such relevant topics. And I want to thank everyone for joining. Have a great day. Talk to you later. Bye-bye.
And thank you, Hao.
Thanks, everyone.